The universe is a beautiful, vast space. It almost seems never-ending, which would explain the fascination of humans wondering what goes on out there in space. In 1969, the idea to build the James Webb Telescope was created. It took 52 years to make this dream a reality. And now, everyone is thrilled that this magnificent instrument that conducts infrared astronomy has finally finished its construction. Today, it is considered as one of the best space telescopes that was launched to study the atmosphere of exoplanets. But scientists are worried about the data coming from the telescope. Are humans really ready to reveal the secrets of the James Webb Telescope? Join us as we find out what daunting images have been caught by this extraordinary instrument. Scientists might misinterpret data from the James Webb Telescope. The James Webb Telescope is the largest optical telescope in space. Its high resolution and sensitivity allow it to view objects that are too old, distant, or faint for its predecessor, the Hubble Space Telescope. The telescope will make it possible to study a wide range of astronomical and cosmological topics, including the birth of the first galaxies, the observation of the first stars, and the comprehensive atmospheric characterization of possibly habitable planets. The initial plans to build the telescope began in 1969. It launched on December 25, 2021, and was fully deployed in January 2022. The James Webb Telescope revolutionized exoplanet research after only a few short months of deployment. The James Webb Space Telescope has so far produced excellent data, from revealing the transmission spectrum of an extremely hot gas giant to finding a super-Earth that may contain a large liquid ocean. Scientists are excited to see what else can be caught by the telescope. But the question is, are they really ready for it? Unfortunately, there is a possibility that they might misinterpret data coming from the telescope. According to recent research, it was stated that scientists could possibly misinterpret data produced by the telescope if the current models are not improved. Atmosphere of exoplanets. Before we talk about the possible improvements of the current models we have, there is a concept you should be familiar with. As observed from Earth, an exoplanet transits its star, causing the brightness to change as it travels through the atmosphere. This is because the exoplanet's atmosphere reacts differently to different starlight wavelengths. The atmosphere's composition of the exoplanet can then be determined by comparing the star's modified starlight to its original starlight. Astronomers use opacity models to interpret the data from telescopes. An opacity model lets astronomers study the spectrum of light after it interacts with the planetary atmosphere. With the help of these models, we can decode the type of chemicals present in the exoplanet's atmosphere. The current telescopes orbiting around Earth, like the Hubble Space Telescope, are doing a great job at decoding these models. But with the type of precision the James Webb Telescope has, we won't be able to notice small, crucial details using our current decoding and translating procedure. Translating data correctly from exoplanets is vital because these details might determine if a planet is habitable or not. If we ever plan to live on another planet, we can't risk miscalculating even a single unit. Before we proceed with the rest of the video, if you are enjoying the content so far, don't forget to like the video and subscribe to the channel. Now let's get back to it. Opacity models. Typically, information is extracted from the supplied data using 1D models. Experts contend this does not adequately represent the variations caused by a planet's temperature asymmetries. These spectral lines are important because they get distorted due to collisions between molecules. Several studies have been affected by this because of unavailable pressure broadening parameters. The most widely used opacity model was put to the test in a recent study to better understand the effect of flaws in opacity models. The researchers also tweak some of these models according to our understanding of light-matter interaction. They used 9 alternative opacity models in a sensitivity analysis to examine the atmospheric parameters that each model would yield. They discovered that each disrupted model produced varied predictions for a planet's atmosphere's characteristics. Our decoding equipment would produce different results for each planet, producing inaccurate results. This would hinder scientists from extending their research about possible habitable exoplanets. It was then concluded that if existing opacity models are applied to light spectra taken by the James Webb Space Telescope, it would not be sufficient to tell the exact atmosphere of the exoplanet. It would be impossible to constrain planetary formation methods and biosignatures using the data collected from the telescope. Moreover, the team also found that every model fit well with the data. In other words, a modified model created a chemical composition that was known to be inaccurate. Still, it also produced a light spectrum from that chemical composition sufficiently similar to the original spectrum. This just means that the data to be processed would be inaccurate, and you wouldn't know if your model is wrong and if the data it's getting is incorrect. This model has so many inaccuracies, which is why scientists are worried about the data coming from the James Webb Telescope. For so many years, they've waited and anticipated for it to be deployed, but now that it's up there, it just so happens that we aren't ready to receive the type of data that James Webb Space Telescope is giving. Solutions to receive more accurate data from Webb Telescope. Now the question is there any way to fix this problem? Can we do anything to keep up with the Webb Telescope? Well, there is a fix. But it won't be quick. We need to combine more theoretical computations and experimental experiments with improving our comprehension of the interactions between light and different molecules. This could take a while to do. We are already familiar with the Earth and its atmosphere, but since there are thousands of planets in space or even millions, it can be quite hard to determine each and every single one of them if we are receiving inaccurate data regarding their atmosphere. It is a giant leap for humans if we ever come across a planet that can be habitable by us. Scientists from decades ago have been working on it, and to achieve this, we need to be aware of these exoplanets' atmospheres. Experts are hopeful that we will soon find a way to be able to fix this, and I'm sure the great minds behind this project are working hard to move us past this problem. Within just a few months of deployment, the James Webb Space Telescope has already proven its capabilities. Our present cosmological models have already been put to the test by the Webb Telescope. Maybe this telescope is just a few years ahead of the science community. While the James Webb Telescope is an exemplary piece of equipment that lets us view images that no other telescope has done, we will never truly know if the images we observe from it are true. Do you think scientists are close to fixing this problem now? If so, how long do you think we will have to wait before we can maximize the use of the James Webb Telescope? Let us know what your thoughts in the comment section down below.